Hello there, this is Mr. LaBeouf with a very limited discussion here of a concept in mathematics known as factorial. And one of my most famous sayings about mathematics is this. Mathematics is all about symbolism, understanding the symbolism, and then being fluent in it in order to answer questions, solve problems. So here's my favorite saying. Symbolism is to math as water is to swimming. It's literally, symbolism is what we do math in or with, just like we swim in water. So here's a symbol that may be new to you, in math anyway, this thing here. In the English language, of course, it's one of the punctuation marks. It means, yeah, like something is really powerful or exciting, emotional, the exclamation point or the exclamation mark. Mathematicians borrowed that to mean something else, and it's called factorial. Now, the word factor indicates numbers that are multiplied together. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. Factorial does have something to do with multiplication, which is why it got its name, but when we have, for example, 12 factorial, we're not being asked what the factors of 12 are, like I just said. Factorial means a very specific thing. It's very easy, and this is part of my message about the symbolism of math. Once you are told what the symbols mean and you work with them a little bit, they're quite obvious and easy to work. 12 factorial means 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? Now that's a pretty big number. I'm not going to try to calculate what that number is. 4 factorial. We can work that one out. 4 factorial means 4 times 3 times 2 times 1, 12 times 2 times 1, 24. So 4 factorial is 24. Very simple concept. Now, I had 2 students recently, fifth graders, who taught themselves factorial. They discussed it amongst the 2 of them, between the 2 of them, and they shared some of it with me. I remember thinking at the time, that's nice, that's cool, but factorial doesn't really enter into middle school math that much, if at all. So I kind of put it on the back burner. But then I realized, I remembered that there are certain kinds of questions that are often asked in middle school math that factorial can relate to. I'm going to focus on one of those things right now. And this symbol and this concept of factorial will come up in high school math every now and then. It's not a huge part of high school math. If you take a course on statistics and probability in high school, which some people do, it'll definitely be in that course. And then also in some of the other courses, maybe in Algebra 2 and Geometry, certain topics will be covered that will use factorial. So it's an easy concept, and it's something that will benefit you in the future. But now let me give you an example of something that's often asked in middle school, and this tool of factorial will be helpful. I've put 4 factorial back up here on the board because I don't really want to deal with 12 factorial. We'd be here for a long time if we did a problem involving 12 factorial. 4 factorial simply means 4 times 3 times 2 times 1, and of course it's 24. Let's take 4 objects, A, B, C, and D, and ask the question, how many different ways can they be ordered? Now, this is one of the ways right here. A, B, C, D is one way to order those 4 objects. Let's go through this systematically. I think the way that is comfortable for me is I'll keep the A and keep the B, and now reverse the C and the D. So now we have a second. There's no other way to do this with A and B first. So let's now start with A and put the C second. And once we put the C second, we can go BD, but we could also go AC and then DB. So now we have all the possibilities for A, B first and AC first. Well, what about now AD? All right. So AD, and then you should see from similar to before, there are two possibilities. Sorry about the glare there on the board. Hopefully that won't be a problem. You could have ADBC or ADCB. Now, if I thought this through correctly, that takes care of all of the possibilities where A is first. Let's just quickly count how many there are. 2, 4, 6. There are 6 possibilities where A is first. Well, we could have B first, we could have C first, we could have D first. And I think it's intuitive. I think you should appreciate that if there are 6 possibilities with A first, then there should also be 6 possibilities with the B first, and 6 possibilities with C first, and 6 possibilities with D first. So 4 times 6. And if you look up here to the 4 factorial, this 3 times 2 represents the 6 possibilities here, and then multiply by 4 to get, the 4 possibilities for the first entry, the A, then the B, then the C. The answer to this question, how many different ways can we order A, B, C, D, is 24. It's 4 factorial because there were 4 objects. Now, these are the first 4 letters of the alphabet. Let's imagine the entire alphabet. A, B, C. And of course, there are 26 objects there. The entire alphabet is 26 letters. So let's ask the question. How many different ways can the letters of the alphabet, and using each one only once, I didn't say that before, but it would be a much different question, a much higher answer, if we could have repeated any of these, if we could have gone A. But we're not doing that. We're just using each element once. Now, how many ways do you think there are to order all 26 letters of the alphabet? Well, the answer is this. It's very easy to write the answer. It's 26 factorial. 26 times 25 times 24 times 23, ... continue all the way down to times 3 times 2 times 1. It's a huge number. I'm going to use a little technology, ladies and gentlemen. There are some calculators, not the basic 4-function calculators, but on this phone here, if I go to calculator, this is the basic 4-function add, subtract, multiply, divide. But somebody taught me, I didn't know this until several months after I had the phone. You turn it on its side and it's what we often call a scientific calculator with more functions like exponents and things like that. And one of the keys has an X with an exclamation mark after it, right there. X factorial. So if I type in a 26 for the 26 letters of the alphabet, and then hit the factorial key, this is the result. This is something that I haven't taught. If you're 6th graders watching this now, I have not taught you about scientific notation. Scientific notation is a way using exponents to write either very big numbers or very small numbers. In science, for example, if you want to write how many kilometers is it to the nearest star other than the sun, it's about 4 light years. How many miles is that, or how many kilometers is that? It's a huge number, and it's often given in scientific notation. Rather than having to write out all the digits, scientific notation is a kind of an approximation. Well, the answer that was given to me here for 26 factorial, it's 4.03, and we can kind of ignore that. This is a very nice result because the second digit, the digit in the tenths place here, it's 0, 4.0. So the part of the number that's first here, 4.03291461126666, that's just a little bit more than 4. But then there's this letter E here, which stands for exponent, and then a 26. What that means is it's a number that's a little more than 4, 4.03, times 10 to the 26th. That's what that E26 there means. It stands for the exponent of a 10. So 4 times 10 to the 26th. And by the way, exponent is 26. There are 26 letters in the alphabet. I didn't really expect that. I think that's just a coincidence. But the point here is, it's a huge number. It's a little more than a 4 followed by 26 zeros. Think about that for a minute. A 4 followed by 26 zeros. A billion. Let's say you guessed. How many ways are there to arrange the 26 letters of the alphabet? Let's say you guessed it was a billion or 4 billion. It's a 4 billion. Okay, because this starts with a 4. The actual answer starts with a 4. Well, 4 billion, let me picture it. It's a 4 followed by 9 zeros. Is that right? A 4 followed by 6 zeros is 4 million. A 4 followed by 9 zeros is 4 billion. This is a 4 followed by 26 zeros. It's incredibly huge. I said at the beginning of the video that had another factorial. I think it was 12 factorial. I said I wasn't going to compute that. And even the calculator can't really do it because this is not an exact number. It has to be rounded to a certain place and then just, tack on zeros. It's an approximation. Scientific notation is an approximation. It's a huge number. You can just, with this, a 2 and a 6 and that exclamation mark there, you get a huge number. So that's factorial. You'll run into it in some high school courses now and then, but it's a very simple concept. It's important to realize, though, if the number gets just somewhat big, 26 is not a very big number, you put a factorial after it, it's a huge number. It's not, by the way, just think about this for a minute. It's not as big as 26 to the 26th power. That's much bigger, right? Now think about this for a minute. You know what all this symbolism means. 26 to the 26th power means 26 times 26 times 26 times 26, 26 times, okay? This is not in that neighborhood, really, because this is 26 times 25 times 24. At the beginning part there, it's maybe kind of close. But then, of course, you get down to times 4, times 3, times 2, times 1. So this is significantly different. This is significantly less than this, but they're both huge. I want to leave you with this one last statement. And it goes like this. Believe it or not, this is a pun. I'm going to tell you now what I'm about to show you is a pun on that as something in the ordinary English language, the exclamation mark like, math is cool! Exclamation. And then the same symbol really, but in math, which means factorial, which I just explained to you. Well, here it comes. Believe it or not, 5 times 24 equals 5. 5 times 24 equals 5. No. Because for this to be a true statement, we can't see this as 5. You have to see it as 5 factorial. 5 times 4 times 3 times 2 times 1. 20. 5 times 4 is 20. Times 3 is 60. Times 2 is 20. Times 1 is 20. 5 times 24 is indeed 120. Or 5 factorial. 5 times 24 is not 5, but it is 5 factorial. Have fun. Math is fun. See you soon. Bye-bye.